So my vertex is going to sit at the point -1, comma, -9. The vertex represents a maximum or minimum. Okay, so we need to look at where the vertex is. If the vertex is at the bottom, that means it's a minimum value. And if it's at the top, that means it's a maximum value. So here, in this case, my vertex would be at the bottom, meaning it opens up. It's at the very bottom. So this is going to be a minimum. My vertex is the lowest, the smallest amount. Okay? I know, again, that was a lot, guys, so let's go on to the second page of these notes. Okay, I'm going to go ahead and make this a little bit bigger here so we can see it. Okay, so let's look at this one. On this one, guys, I'm going to give you guys the equation, not in standard form this time. I'm actually going to give it to you in factored form. And this equation is going to say f of x equals x minus 3 times x minus 5. Now you're probably thinking, well, Mrs. Stan, how the heck are we going to get this in standard form? Well, remember those cute little biology boxes that we used to do? Yeah, we're going to multiply that, x minus 3, x minus 5. I'm not going to fill out all that right now, guys. What you'd eventually get would be x squared minus 3x minus 5x plus 15. Combine that middle, and my equation is going to say y equals x squared minus 8x minus 15. Okay, from here we can look at our x-intercepts. Well, if I looked at that factored form tells me that x would equal a positive 3 and a positive 5. So my intercepts are going to be 3, 0 and 5, 0. So let's go ahead and put those on this graph right now. So we're going to do the 0.30 over 3 up 0 and the 0.50 over 5 up 0. So those are my x-intercepts on the graph. I know it's a little covered up by those words down there at the bottom, but you guys get the picture of it. Okay, the next thing I want to talk about is the y-intercepts. Again, this is when x equals 0. So I'm going to say that y equals 0 squared minus 8 times 0 minus 15. And what I end up getting is negative 15 as the answer. Sorry, not negative 15. Wow. Positive 15. Let's go back and change that. See, I don't have a regular class right now to correct me on these things. So with this, guys, when x is 0, my y-intercept is going to be 15. So I can go over to my graph and go over 0, up 15, and put that dot there. Now let's go back to my equation. For my leading coefficient, again, we're looking at that a term, the number that's with that squared term, and my a term is 1. What is my axis of symmetry? For that, again, I told you guys, negative b over 2 times a. So negative, and then my b in this problem is negative 8 over 2 times a, which is 1. Simplify that, I get positive 8 over 2, which equals 4. My axis of symmetry is at x equals 4. So I'm going to, again, go over here, and I'm going to draw this dotted line showing you where that axis of symmetry lies. Now I'm going to show you guys something that I didn't on the last problem. Because this is an axis of symmetry, I know that if I have my y-intercept right here and it's 1, 2, 3, 4 spaces over, I know that over here it's going to go 1, 2, 3, 4 spaces over, and I can put another dot there. I drew those lines just to show you the symmetry there. So I now have those 2 points. I now have 4 points of this graph. The problem is we don't know what the vertex is. Looking at this, I can see that my A term was positive, and so I know that it's going to open up. Now let's go ahead and find that vertex. I told you guys that we're going to take this axis of symmetry up here and plug it back into our original equation for x. So we're going to say that y equals 4 squared minus 8 times 4 plus 15. And when I simplify that, that's 16 minus 32 plus 15. Again, I'm not asking you guys to do this in your head. Go ahead and use your calculators on that. And you get that our vertex, the y value of the vertex is going to be -1. So we're going to take the x value, which is your axis of symmetry, which we said was 4, and then that y value we just found is -1. So I'm going to come over here and go over 4, down 1, and put a point there. From there, guys, you can go ahead and draw this up. Make sure that's a curve at the bottom and not a point. And that's what your shape looks like. When you guys look at the vertex, is it a maximum or a minimum? We can see that it is the lowest point. That is the lowest point down there. And so because it's the lowest, it's going to be the minimum. Okay, let's do another example here. Going down to the last problem that we're going to do together. Okay, so on this problem, I give you guys standard form. There we go. On this problem, I give you guys standard form. Now you're going to notice something right away here. My front term here is a negative. So what does that mean? What that means, guys, it means a whole bunch of stuff. But the first thing we need to do when we go to write this equation in factored form is to take out a GCF. Okay? You need to divide out that negative. When I do that, I get that y equals -1 times a positive x squared plus 4x plus 4. So now I can go ahead and factor this. Okay? So with this, what multiplies to 4 but adds to 4? Well, that's 2 and 2. So the factored form of this problem is going to say y equals -1 times x plus 2 times x plus 2. And you guys may notice something. You may also say, well, hey, Mrs. Stanton, can't we write that with just x plus 2 squared? And the answer is yes, you can. But for this, we don't really need to right now. We're going to see what happens with that, though. Okay, so let's go down. Let's talk about the y-intercepts here. Well, that means that we take these factored forms and we set each of them equal to 0 and solve for x, and I get that x equals -2, and then I do it again, and I get that x equals -2. Well, they're the same exact point. What does that mean, guys? We only have one intercept, and that is at -2, 0. So we're going to see what happens with this. -2, 0. Okay? The next thing is for that y-intercept. Again, we're going to say -0 squared minus 4 times 0 minus 4. With that, guys, all we get is that the y-intercept is -4. 0, -4. Okay, so I'm going to go over and go down to 0, -4 and put a point. Okay, so now we got 2 points on here. Let's go look at that leading coefficient. My leading coefficient is a -1. A is -1. My axis of symmetry, this is going to be -b, so negative of -4. This is using the original equation, guys. -b all over 2 times a, which is negative 1. That gives me a positive 4 over negative 2, which equals negative 2. My axis of symmetry is at x equals negative 2. So I'm actually going to put this in red here. Negative 2. What do you guys notice there? That axis of symmetry runs right through our one intercept. Okay. Which way is this parabola going to open? Again, let's look at our leading coefficient. Our leading coefficient here is negative. Negative means that it's going to open down. Okay? So it's going to take the shape of this. Now let's go back and find the rest of our vertex. We know we have the first part of negative 2. We don't know the second part. So we're going to go ahead and plug that negative 2 into the problem. And we're going to say y equals negative of negative 2 squared minus 4 times negative 2 minus 4. When I simplify this out, I'm going to get negative 4 plus 8 minus 4. And what that equals is 0. So that second point, or the second part of the vertex is going to be 0. Well, look at that, guys. Negative 2, 0, that's our intercept. Okay, so I know that this y-intercept here is 2 spaces from the axis of symmetry, so I'm going to go 2 spaces here. And we've got ourselves a graph here. Again, try to make that more of a U, not a V like I just did. Now, looking at this graph, does it represent a maximum or a minimum? It's facing down, which means the highest point is at the top, which means that's the maximum that it could be. Okay? So, real quick, guys, before we wrap up here, I want to talk about just a very quick recap. So, we're going to say here the big things to note. Okay? If our leading coefficient, if A is positive, it's going to open up. If A is negative, it opens down. Okay. If you factor the problem, that gives us our x-intercepts. Okay? To get our y-intercepts, we're going to plug 0 into x for the y-intercept. Okay? To find our axis of symmetry, our AOS, I like to call it, the axis of symmetry, okay, we're going to do negative b all over 2 times a. And that gives us an x equals format. To get our vertex, we're going to use your axis of symmetry to plug into x. In the equation. To find the y. So that our vertex is sitting at the point, our axis of symmetry here, and then the y value here. If you guys have any questions on this, please feel free to email myself if you have me. Otherwise, email your specific Algebra 1 teacher, and we can get these questions answered for you. Go ahead and start working on that practice, and you guys will find a worked out answer key also attached. Again, if you have any questions, please, please, please email your teachers.